So to find the equation of a circle, you want to think of when we did a parabola, we had an x squared in our formula, which made a curve. For a circle, you're going to have an x squared and a y squared, so that it kind of makes two curves and connects it to make an entire circle. So let's do, for the first one, sketch the locus of points 5 units from the point -1, 2. So you want to envision that -1, 2, right about here, is the cup that I put on the ground. And you want to be 5 units away. So remember, it was 5 units to the left, 5 units to the right, 5 units up, 5 units down. And the shape of this should be a circle. So I want to complete this by trying to make it look like the shape is a circle. And it's a pretty good circle. We kind of want it to be dotted or dashed, so you could go around it if you wanted to with kind of a dashed line or a dashed circle. Locus, we should always try to keep them dashed or dotted, because I want you to visualize it's a series of points 5 units away from the point -1, 2. So the tricky part is, what's the equation of this circle? I kind of talked to you about it in the beginning, saying that y squared and x squared are going to be part of it, because you want to make sure that you have a curve and then another curve to connect to make a full circle. So some things that I do normally is I kind of say, what is a point that perfectly lands on this graph from the circle, besides for these anchor points? Because this circle, there's actually more points that land perfectly on the graph that are on the circle, and they land perfectly on the grid where the X and the Y lines are crossing. So when I'm looking at this, I'm kind of seeing like right here. It looks like it lands perfectly. And there is a way to check. I'm going to kind of build a triangle within here. Now, keep in mind that a radius of the circle, we were 5 units away. That means it should be 5 units up, down, left, right. Also, it's going to be 5 units diagonal. And so any center to a point on the circle is a radius, and they're all got to be the same. I can actually count along the bottom here. That's 4 blocks. And I can count the height of this triangle is 3 blocks. Are these numbers ringing a bell at all? I think when we have a right triangle, we normally do the Pythagorean theorem to figure something out. If we have all 3 sides, we can kind of check in the Pythagorean theorem. It looks like we have a right triangle because the Pythagorean theorem checks here. The equation for the circle is actually derived from the Pythagorean theorem. So think about how I got this 3 and how I got this 4 and how I get this 5. So for the Pythagorean theorem, we have something squared plus something squared equals something squared. A squared plus B squared equals C squared. Oops. So it's kind of obvious that at the end, we've got 5 squared in here. So we're going to have something squared something squared, equals the hypotenuse squared, or in our case, the radius squared. Okay? And the trick is, how do we get 3 and how do we get 4? If we look at the points of which we started with, this point was negative 1, 2. This point is 3, 5. So how, looking just at these 2 points, can we get 3 for the height of this triangle and 4 for the width of this triangle? So if we're looking at just the x numbers, it goes from negative 1 to 3. How many spaces is that? It's 4 spaces to get from negative 1 to 3. So we're going to use our x's over here. We're going to have negative 1 to 3 to get 4 spaces. I'm going to try this. 3 take away negative 1. And that will give me 4 for the base of this triangle. And all I did was I took the point on the circle and subtracted this. If we do something similar with the y values, we'll get the height. The height is determined by the y values because we're going up and down. So 5 and 2 are my y values. How do I get 3? 5 minus 2 gets me 3. And I'm putting it in the wrong spot. And when I check it, I'm going to get 4 squared and 3 squared makes 5 squared, which I checked over there, which it equals. Now the tricky part is, this is how you develop the general form of a circle. You end up with 2 x values and 2 y values that we subtracted. We're going to call the center HK. And these points then over here, x, y. So technically you took x and subtracted h from it. And you took y and subtracted k from it. The 2 y values. This is your general form for the equation of a circle. Now, for the equation of this specific circle, we typically, for equations, we leave the x and we leave the y, and we substitute all the other variables. So for this specific equation, we would leave the x and we'd substitute in what the h is. So keep in mind, I labeled the h in the middle here. H is my center point, and I need the x value from the center point. That's what the h is standing for. If you want to look all the way up here, some people will put HK. The center point, you can't really call it XY because the point on the circle was XY. So we want to identify it as something different. We might call it HK. I didn't make it up. That's what the standard is. H was negative 1 plus y minus k is plain old 2. And we substitute in the radius of 5. So the actual equation for this circle is messy. The one thing that I probably would do is I probably wouldn't have 2 negatives in a row like this. I would probably have x plus 1 squared plus y minus 2 squared. And you could even change this to 25 at the end. And this is the equation for that specific circle over here. So you could write it either way if you didn't want to simplify it, but I would probably simplify it because I'm going to give it to you most simplified as well. Now, the trick is that you might start seeing a little bit of a pattern within this, because at first it looks very messy, but let's try another example. sketch the locus of points 2 units from 4, 3. And I'm going to put after it, write its equation. So the first step is, can you accurately do it? You want to start at 4, 3, and imagine that's where I put a cup on the ground. And you want to go 2 units away. That means 2 units up, 2 units down, 2 units left, 2 units right. And then fill in all the other so that's it accurately sketched. Writing its equation. You can do it a few different ways. Why don't we look at the original equation that we built up here? So in an equation, we want to keep the x and the y, and we want to substitute in h, k, and r. So a lot of times I'll have students write it down. What is h? What is k? What is r? And keep in mind, the center point here is called hk. So the center point is 4, 3. That means 4 is my h, 3 is my k. How much is a radius? How much is it to get from the center to the edge? 2 units away. And now I'm just going to substitute in the information. So my final answer is x minus, put in 4 for the h, 3 for the k, and 2 for the r. And I could have that as my final answer. Or I could even go a step further if I wanted to. You don't distribute these or FOIL, if you remember FOIL from before. You want to leave them within. The only thing that I would do, if you want to, you can take 2 squared and change it to 4. So let's turn the page and build 2 more graphs. And let's try another one. Sketch the circle. X minus 2, y plus 4 squared equals 9. So what do you need when you want to sketch a circle? You need to know where to point the center and how far out to go. What's your radius going to be? So we need our center. We need our radius. Probably the easiest way to think about this is, can you rewrite this in the general form? X minus h. Whatever you put in here is going to be our h. X minus 2. I'm just copying down what was up here. Y minus something. This is going to be our k. The formula has y minus something in here, but I've got y plus 4. So can I rewrite y plus 4 as y minus something? Y minus a negative 4 means the same thing as y plus 4. And I want to put in here something squared, but it needs to be equal to 9. That something is my radius. What squared equals 9? 3. So now my center, which is at HK, I know is at 2, negative 4. And my radius is 3. Now it's a lot easier to graph. 2, negative 4, and a radius of 3 means up 3, down 3, right 3, left 3. And it doesn't really matter if you do this one dotted or solid because the problem doesn't have the word locus in it. And that's your equation and that's your sketch. You might notice that if you look at it right off the bat, negative 2, positive 4. And then where was your HK? Positive 2, negative 4. It's always going to be like that. Whatever signs you see, it's going to be the same numbers, 2 and 4. But if you see a negative 2, it's going to be a positive 2 for the center. Positive 4 with the Y, then it's a negative 4 for the center point for the Y. So that is something that some people will notice, and then it makes it a lot easier. Last one, sketching x squared plus y plus 2 squared equals 8. Keep in mind the general equation says x minus something plus y minus something equals something squared. What must I subtract from x and get x again? Basically, what could you subtract from your age and still get your age? Only thing you could subtract away is 0 and keep the number the same. Y minus negative 2 is going to give me y plus 2. Here's my h and my k. So I know my center is at 0, negative 2. Radius, I'd like it rounded to maybe the 10th place. What number squared is 8? Well, it doesn't work out perfectly. It'd be nice if it was 9. We just did that one. 9 worked out to, the radius was 3. 8, the radius is going to work out to something in the 2s. But 2 squared is 4, 2.5 squared, it gets kind of tricky. So, what squared equals 8? One thing to think about. The square root of 8 squared equals 8. Because when we square something and we square root, it's actually undoing the process. So the radius is the square root of 8. In a decimal, I think it works out to 2.8. You can double check me. And remember, it says sketch. Okay, it's not going to be perfect. Start at 0, negative 2, and try to go about 2.8 spaces away. That would mean I wouldn't want to go 3. I'd want to go a little before 3. It's a sketch. It's okay. On a Regents exam, you'll be provided with a compass. And if you're not, you could always ask for one. And then you could make a nice circle using a compass. This looks good. Dotted, solid, it doesn't particularly matter.